Okay, class, in this lesson, you're going to learn to use both the SAS and the SSS triangle congruence to determine whether triangles are congruent. Okay, so let's go ahead and get started. With the first theorem, we have the SAS, or better known as the side angle side congruence criterion. And basically, this theorem is saying that if two sides of a particular triangle, so let's say side ST and SR, and its included angle, so angle S, okay, so notice that this angle is in between this side and this side. If those two sides and the included angle are exactly the same as that in the second triangle, so side YZ, XY or YX, and angle Y, if those are equal to this first triangle, then both triangles are congruent. Now remember, the word congruent means that they are exactly the same, okay? So let's go ahead and break this down a little bit further. In the first triangle, we have side ST, and we have this single hash mark, and we also have in the second triangle side YZ with a single hash mark. Okay, so those single hash marks basically indicate that both of those sides are the same. So ST and YZ are exactly the same. Second, we have angle S and angle Y, and we have these markings, these little arcs. Those indicate that those angles are exactly the same. Okay, and then third, we have side RS and side XY are also the same because of these double hash marks, okay? And because all three of those things exist, and in the order, or in the fact that this angle S is in between these two sides and angle Y is in between these two sides, because of those scenarios, then we know that both of those triangles are congruent. Okay, so that's one of the theorems, and let's move on to the second theorem. Okay, the second theorem is referred to as the corresponding parts of congruent triangles are congruent. All right, so that's a mouthful, but let me go ahead and break this down for you. So basically, what we're saying is if triangle ABC, okay, triangle ABC, and triangle XYZ, so this is XYZ, if we're assuming that these are congruent, okay, then each of their components are also congruent, okay? So, for example, we've got triangle ABC, okay, or let's take the first two letters, side AB, okay, so side AB, so this is the side AB. That side is equal to or congruent to side XY, okay? And the reason we know that is because we're told that both of these triangles are congruent. So because they are congruent, then side AB is the same or congruent as side XY, as stated down here. Okay? Furthermore, side BC, okay, notice it's the second and third letter of the triangle, and in that order, side BC is also congruent to side YZ, which is right here, YZ, and in that order too, right? Second and third letter of the second triangle. So this is what it says here. Side BC is congruent to side YZ. Third, we're told that side AC is congruent to side XZ, okay? AC is right here. This is that long side, and it's congruent to XZ. Notice that AC is the first and third letter, and XZ is also the first and third letter of that triangle, okay? Now, I'm stressing the order of the letters because it's very important to recognize that the order matters, okay? So side AC, XZ, AC, XZ are also congruent. Okay, so those are the sides of the angle, and we've covered all three sides. Now we're going to go and shift gears towards angles. Okay, so here it says angle A is congruent to angle X. Okay, Angle A, notice it's the first letter of that first triangle, and angle X, it's the first letter of that triangle. And here, angle A and angle X are congruent, okay? Then we go to the next letter, angle B, and the second letter of the second triangle is angle Y. And notice that those are also congruent. So here's angle B, here's angle Y, okay? And then the third angle is angle C. This is the third letter in this triangle. And angle Z is also the third letter in this triangle. And we're told that those are also congruent, okay? Angle C and angle Z are congruent, all right? So just to summarize again, if both of these triangles are congruent, meaning they're exactly the same, then each of their corresponding sides and each of their corresponding angles is also congruent. All right, so let's go ahead and apply those to this next example, okay? So in example 1, we're told that in a marching band, Caden and Latoya start 10 yards apart, okay? Caden starts here, Latoya starts here. Caden marches the path in blue, so he goes 20 yards in this direction, and then at 110 degrees, he goes 25 yards in that direction, and then comes straight back to where he started. And then Latoya moves in this direction at 15 yards, and then at 110 degrees, moves 20 yards in this direction, and then moves to where Caden started, and then returns to where she started by moving 10 yards, okay? So those are the respective paths. And the first question is, are the triangles formed by the paths congruent, okay? Are they congruent, meaning are they exactly the same? Well, let's take a look. Caden moves 20 yards, so that's one side of the triangle. Latoya also moves 20 yards, so we see that. We have two of the same thing. Then Caden shifts gears at 110 degrees. Latoya also shifted gears at 110 degrees. And then Caden moves 25 yards. Latoya moves from here to here. That total is also 25 yards, okay? So we've got a side, angle, side that matches side, angle, side, all right? So then the answer to the first question is yes. Oops, let's go ahead and change the size of the line there. It is yes because of side, angle, side congruency. Okay, so let's move on to part B. Are the angle measures that Caden and Latoya turn at points A and B the same? Okay, so is this angle equal to this angle? Well, based on the second theorem that we learned, okay, we just proved or demonstrated that because of side, angle, side, we know that this triangle is the same or congruent to this triangle. So the blue triangle is congruent to the magenta triangle, okay? Because they're congruent, then each of the corresponding angles are also congruent. And so we know the 110 are the same. We know these angles are also the same. They're also vertical angles. And so what's left is angle B and angle A. And because both the blue triangle and the magenta triangle are congruent, then we know that angle A and angle B are congruent, okay? So we could say angle A is congruent to angle B, okay? And we know that from the explanation that I just provided. Okay, so let's go ahead and move on to the next theorem. All right, this next theorem is probably the easiest of the theorems that you'll learn, and that is if three sides of one triangle, so here's one triangle and we've got three sides, if each of these sides are congruent to the sides of another triangle, so this side is the same as this side is the same as that, and this side is the same as that, okay, then what we have are congruent triangles. okay? So, and I should have labeled this. I would say that triangle ABC is congruent to triangle DEF. Okay, so those triangles are congruent, and this is via the side congruency, okay? Because all three sides are equal to all three of these sides. All right, so let's go ahead and take a look at example 2. Okay, we're going to go ahead and explore the theorem that we just learned. And the question is triangle ABC, is this triangle here congruent to CDA? Okay, well, let's take a quick look. We know that segment BC, or side BC, is congruent to AD because of the single hash mark. We also know that side AB is also congruent to CD because this is double hash mark. And both of those triangles share the same side. So the answer here is yes, they are congruent because of side congruency. All right, let's go ahead and move on to example number 3. Okay, so we've got pairs of triangles here. We've got 4 sets, and the question is, are these triangles congruent? Okay, so let's take a look at this first pair. We have this side congruent to this side congruent to that, and this side congruent to this because of the hash marks. So we know those triangles are congruent via the side congruency. And let's move over to this triangle, okay? We have this side congruent to this side. We have this side congruent to this side because of those hash marks. And the angle included between these two sides is also the same as this angle between these two sides. So then we would say that these are congruent via side congruency. Okay, let's move on to the third pair. We have this side equal to this side. We've got this side equal to this side. And we have this angle equal to this angle. However, this angle is not included in between these sides, okay? This angle is not included. It's not in this angle. It's outside of these two sides. It's kind of off to the side. So we would say that these are not congruent. And then the last pair, we have a side here, both of those are the same. This side here and this side here are the same. And we have the angle included inside these two sides, also equal to that. So we would say that these are congruent by side. Okay, and then the next question here is, what additional information is needed to show that triangle ABC is equal to or congruent to triangle DEF by side. So what it's asking is, for the pair, okay, for the pair that is not congruent, what will we need for those to be congruent by side? Well, in order for these two to be congruent, the angle within that's included, so this angle here, I'm going to use a double hash mark, has to equal that angle. Okay, now we have a side angle side. So that is the additional information that is needed to show that those two triangles are congruent by side congruency. Okay, congruent. All right, let's take a look at the last example. Is triangle PQR, so that's PQR, congruent to triangle PSR? Okay, is it congruent to PSR? Well, let's take a look. We've got this side, PQ, is congruent to side PS. So we got one side. We've got this angle. That's also congruent to that angle. And both of those triangles share side PR. And so we have a side angle side scenario. So then the answer to this is yes, because of side angle side congruency. Oops, spelling this wrong. E-N-C-Y. Okay, hopefully that made sense. If any of this was not clear, please go back to the beginning of the recording and listen to this again. Thank you.